Back to the basics, part 2. We're talking the order of operations. Now, before we get into the nitty-gritty of what the order of operations is or how do you evaluate the order of operations, we need to talk about why there's an order in math. Just like there's an order in life, you need an order in math. I have lots of students every year who will take an order of operations problem and say, Mr. G, I got an answer. I used all the operations that I saw there. Well, if you don't have them in the right order, you will get an answer. Just like you can get an answer by smashing your hand against a keyboard, your calculator will spit out any number. It's only as good as its user. So we need to think logically. We need to organize our steps. We need to use the order of operations. This is why we show our work and follow our order. To highlight this a little better, the emphasis on how important the order of operations is, let's take a little story. Imagine one day you decide to go eat a healthy amount of Taco Bell. Now, there is no healthy amount of Taco Bell because it's all pretty much going to kill you. But logically, a little bit later, your stomach's going to get a little rumbly. You're going to want to sit down on a toilet. A good safe place to be considering what step 3 is. Now, we've used unicorn poop here to censor for our sensitive audience members. All the steps are there. Eat tacos, go sit down, do your business. What if I took those steps and reordered them? It makes a major difference. You eat the tacos, then you take a poop, and then you go sit down. So you aren't on the toilet yet. That's a major difference. You either need to explain yourself to your friends and coworkers, and you probably need to get a new pair of pants. The point is, just because you followed the steps doesn't mean you got to the logical or correct answer. So let's look at the actual order of operations. We want to retire Dear Aunt Sally. That's the old adage. What is the order of operations? Oh, please excuse my dear Aunt Sally. Well, yes, but can you tell me what E stands for? Can you tell me what dear stands for? What aunt, what Sally means? Every student on earth has memorized, please excuse my dear Aunt Sally, but don't take the time to memorize what they stands for. So we just use PEMDAS. PEMDAS, plain and simple. Our P is parentheses. Now this is not just parentheses, it's all forms of grouping symbols. E, exponents, which we talked about yesterday, is powers and exponents. Multiplication and division, they are grouped together because they are inverse or opposite operations. You do not just do multiplication, then do division. You do multiplication or division, depending on which one you find, going left to right throughout the algebraic expression. Then we have, same policy, addition and subtraction. They're inverse or opposite operations, so you have to do them from left to right. Not addition, then subtraction. You do whichever one you see first, from left to right throughout the algebraic expression. There's a simple 3-step method that you can follow to help you show your work. Remember, this is the organizational process. A calculator is well and good, but if you do not take the time to plan out your work, you will not accurately type it into the calculator. So, step 1, you need to underline. We underline the operation that we need to take care of, whichever operation is next in the order of operations. Then we evaluate. That's another word for calculate. This is when you plug your calculator in. That's a calculator moment right there. Every time you underline, then you evaluate. This way we're only typing in one operation at a time. Multiple operations means multiple chances for an error. So we underline, we evaluate, and then we rewrite. We are simply rewriting the problem over and over and over, different versions of the problem, where each time another operation happens, which ultimately makes the problem look shorter and shorter and shorter until it's one final value. So let's look at the very first one. 3 minus 6 divided by, in parentheses, 3 plus 3 minus 1. Now, a good way to get through the order of operations is to simply write the word PEMDAS. So I'm going to write the word PEMDAS. And as I go, I'm going to cross things out. Well, the first operation, this one, some of the work's already been started for us. The first step was to do parentheses. 3 plus 3 makes 6. I underlined the 3 plus 3. I found that that's 6. I rewrote everything around it. I was left with 3 minus 6 divided by 6 minus 1. I see subtraction, division, and another subtraction. So going left to right, I don't see any exponents, so I can move past those, and I see division. No multiplication, but there's some division. I've done that. 6 divided by 6 is equal to 1. I rewrote everything around it. Now let's pick up where they left off. 3 minus 1 minus 1. I'm only left with addition, subtraction. I go left to right. So I don't do 1 minus 1 first. I do 3 minus 1 first, left to right. I underline. I evaluate. 3 minus 1 is 2. I rewrite. Everything that's not underlined needs to be rewritten just as it is. Positives, negatives, operations, values, grouping symbols, everything needs to come straight down. I only have one operation left. I underline, I evaluate. 2 minus 1 equals 1. I'm down to one value. That's how I know I'm done. I have no more addition, subtraction, so I'm out of operations. That's my final answer. We'll try the next one. I see 2 sets of parentheses, so I'm just going to start with the first one. If there's multiple sets of parentheses, start with the one on the left. Just like addition, subtraction goes left to right, multiplication, division goes left to right. So I'm going to underline 4 minus 2. Well, I know 4 minus 2 is 2. Again, that's a calculator moment. These tiny one operation at a time problems make using the calculator very easy. 4 minus 2 is 2. Everything that wasn't underlined, everything that didn't calculate comes straight down. Now those parentheses are done. I don't need those parentheses anymore, so I can get rid of them in my order of operations. Now I'm going to look. I have one set of parentheses done. I still have another one. Now that set of parentheses has a lot going on. 7 minus 2 squared. When there's more than one operation inside of a set of parentheses, you need to treat it like the order of operations again. So let's look at PEMDAS. Write it out again. Just for that one section. There's no other parentheses in there. I see exponent, so I'm going to take care of my exponent first. I'm going to underline, I'm going to evaluate. 2 squared is really just 2 times 2 equals 4. Now I rewrite. Everything that wasn't underlined comes straight down. I'm done with my exponents, but I'm still inside that set of parentheses, so I'm still dealing with the order of operations in the parentheses. I have no multiplication, division, but I do have addition or subtraction. I see subtraction. 7 minus 4 equals 3. I underline, I evaluate, I rewrite. Everything that was not underlined, everything that did not calculate that 3 comes straight down. 2 times 12 divided by 3. Now I'm finally done with that set of parentheses. Now I can go back to the regular order of operations, not the one that was inside the set of parentheses. I see multiplication, I see division. I know for multiplication and division, I go from left to right. So I'm not going to divide first, I'm going to multiply first. 2 times 24, so I underline, I evaluate, I rewrite. There's only one operation left, it's division. 24 divided by 3 gives me 8. I underline, I evaluate. There's nothing left to rewrite. There's my answer. On your own, try the next problem. Now, nested parentheses. This is when we have grouping symbols within grouping symbols. These problems add on extra steps. They're a little more challenging, but not if you really take the time to plan for them and take each step. When we talk about parentheses, we mean all grouping symbols like we discussed on the last page. This can include all the following symbols. So we have parentheses, brackets, we have the fancy brackets, I don't know the name of them. We always start at the center of nested parentheses. Always start at the center. The best way to remember this is to think about those really, really, really old Tootsie Pop commercials.
Mr. Turtle, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
I never made it without biting. Ask Mr. Owl.
Mr. Owl, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
Let's find out. 1, 2, 3, 3.
So nested parentheses are like eating a Tootsie Roll. You don't want to eat the hard candy shell. It's hard to get through. You want to eat the Tootsie Roll center. So we always start at the center of a group of parentheses. So let's try the first one. 3 divided by bracket 2 plus 1 plus parentheses 4 minus 4 squared bracket. So inside those brackets, there's a set of parentheses. Now again, we discussed on the last page, we start with the order of operations every time we enter a set of grouping symbols. So in this case, it's logical that if we ignore the 3 divided by, if we ignore everything outside of those brackets, The parentheses inside the brackets is where we need to start. But instead of thinking through each step like that, just remember, nested parentheses go for the center, the innermost set of brackets or parentheses. So 4 minus 4 became 0. That became one value, so the bracket, or the parentheses in that case, dropped out. 0 squared, I had to follow the exponent, so 0 squared became 0. All I was left with was addition, subtraction. This is where we pick up. We underline 2 plus 1. We evaluate to get 3. We rewrite everything else. Still inside those brackets, 3 plus 1 is 3. Underline, evaluate, rewrite. 3 divided by 3. I underline, 3 divided by 3 is 1, and that is my answer. Now let's try the next one. There's multiple sets of parentheses inside the parentheses. So let's look. We want to start at the centermost. Now in this case, there's 2 centermost sets of parentheses. So I go from left to right. I'm going to start with the left set of parentheses first. 5 minus 3. I underline, I evaluate, I rewrite. I still have a set of parentheses inside the bigger set of parentheses. So I'm going to take care of 4 plus 3. I don't look at the full set. I need to look at part, the innermost set of parentheses. 4 plus 3. I underline, I evaluate to get 7. I rewrite everything. Now I'm left with multiplication and multiplication and subtraction. I know that PEMDAS, I'm taking care of my parentheses. I have no exponents. Multiplication division from left to right is next. So I'm going to take care of that. 2 times 5 is 10. I underline, I evaluate, I rewrite. I'm left with just subtraction inside the parentheses. 10 minus 7, I get 3. I underline, I evaluate, I rewrite. Now I'm outside of the parentheses. Now, once you're outside the parentheses, you have to start the order of operations over again. I'm done with parentheses. I don't see any exponents. I'm on to multiplication division. Oh, I see division. 1 operation left. I underline. 15 divided by 3 is 5. I rewrite. There's nothing left to rewrite, though. On your own, try the last problem. Remember, always look for the nested parenthesis, the Tootsie Roll center of that Tootsie Pop. You want to start at the sweet spot right in the middle. All right, thanks for stopping by, and I'll see you in class.